Well, good evening, everyone. My name is Marcel Prasetya. I'm one of the software engineers working on Google Wave. I work primarily on the robot API, specifically on the Java part of it. And I'm a wave mechanic, if you can see from my t-shirt. So before we get started with the presentation, so I'm just going to give you guys a brief introduction of what Google Wave is. So Google Wave is an online tool for real-time communication and collaboration. So a Wave itself is a hosted tree structure of conversations. So I said it's hosted because it lives on the server, and it's shared across all clients that are viewing that particular wave. And it's also live. That means that updates on one Wave client will be transmitted in real time to other Wave clients. So my manager, Lars Rasmussen, he started this project with his brother, Jens Rasmussen. So they're the two co-founders. When they started the project, they have like three things in mind. So we call it the 3Ps. So the first P is product. So Google Wave itself is a product. So Google Wave is the web application that people can use and access to collaborate on waves. So I'm just going to give a brief demo on Google Wave itself. So I assume by now you all have access to a Wave Sandbox, and if you don't, probably want to talk to Shasha, we can collect your email address and we'll see what we can do about that. So this is the Google Wave interface. So we have 4 panels. So on the top left is the navigation panel that contains a series of links that you can use to trigger like many different search. Like inbox is actually a search across all waves that's in your inbox. All search for across all waves, and you can also see like waves that are in your safe search or in your folders and things like that. I have searches and folders here. We also have context panel on the lower left there that allows you to search for your contacts, and it also displays a list of your friends, your contacts, and if you click on that, it will pop up a mini like business card style like contact, and you can use this to create a new wave with. In this case, if I click new wave, I'll make a new wave with me and Dan in it. I can also use this to ping Dan, and I can search on recent waves that has me and Dan in it. So the second panel in the middle here is the search panel. So it has several different components. So on the top part, it has the search box that you can use to perform search. We support different like search term and search keywords like in, from, with, and also like just free-form search, free-form text search. We also have the toolbars. Let me see if I highlight one of my wave, and then the toolbar will be active, and you can perform some actions like archive this wave, mute this wave, move it to inbox, mark it as spam, mark it as read, and things like that. And then this panel itself is the search results panel that contains a list of waves that matches the search criteria that you put in the search box. And on the right-hand side, this is the wave panel. On the top of the wave panel is the participant list. So this displays a list of participants that has read and write access to this particular wave. At this moment, I only have myself in this participant list, but I can add my colleague Seth here to there using the plus button, and that will display a mini contact list, a contact picker. And you can click on the participant panel, and that will display the same pop-up as in the contact panel. And the wave panel also has a toolbar that contains several actions like reply, playback, archive, mute, and spam, mark it as spam. And underneath is the blip panels. So a blip is a unit of conversation. So a wave contains multiple wavelets, and each wavelet can contains a series of blips. And then this rectangle here is a blip. So for example, I have this root blip here with the title of Google Wave Demo, and then I type in hello world, hi SF jug users, and then I reply to that, made another blip, and then I can also reply again, say yet another blip, if I can type, like so. And then this picture here, that avatar picture displays who created that blip. And let's say if someone also edits that blip, let's say if Seth edits that blip, it will also put Seth's picture in here next to my picture. And at the bottom here, we have tags panel that display a list of tags for this particular wave. Right now, I don't have a tag for this wave, but I can mark it, say, as public if I want to. And you can search by tag as well. So in your search panel, you can say, I think, tag public. And that will find that wave that I'm tagged as public. Do you guys have any questions so far? All right, so that's Google Wave. A very short intro of Google Wave. So that was the first P product, the Google Wave web application itself. So the second P is platform. So we want to make sure that Google Wave is extensible and accessible as well. So that's why we develop a set of APIs to make sure that we can make that happen. So we have Embedding API that make it easy for user and developers out there to embed Wave on any given website. We also have extensions APIs that has gadgets and robot APIs that allows you to extend the core functionality of Google Wave. And the third P, we have protocol. So this is for Google Wave Federation. So we know that the internet is built on top of open standard and open protocol. So we don't want to make Wave as yet another siloed communication tool. So that's why we think it's very important to make sure that the Wave technology is based on an open standard, open protocol that everybody can contribute, and better yet, everybody can adhere to, so that different Wave providers can interop and intercommunicate with each other. So in today's talk, I'm going to focus more on the platform and the protocol side. So my product manager, Dan, asked me to also give a brief demo about the Wave Federation. This is one of our latest and bleeding edge demos, so we'll see if that works or not. Finally, I'm also going to talk a little bit about our roadmap, like what kind of features that we're currently working on the API side and also on the federation side, and what's coming and what we have in store. So a couple links. So we have two instances of Google Wave. First one is the developer sandbox, and that's where you guys, developers, can use you can use the server to test and build your robots and gadgets and extensions. Now we've opened up the federation port on Wave Sandbox as well, so you can use that to try out to deploy your own Wave server and try to talk to Wave Sandbox. And second instance, we have the public Google Wave preview. That's basically our production instance that we roll out to a set of consumers. And for all of our documentations, we also have a Google Code site. We have comprehensive tutorials on our Embedding API, Gadgets API, Robots API. We also have some reference documentations on those APIs, like the Java doc, JS doc, PyDoc, and stuff like that. And finally, we also have a blog, googlewavedev.blogspot.com. That's usually where we make announcements if we have like new features, new release, or new milestones. All right, so now let's just jump into the API. So the first API that I'm going to talk about is the Embedding API. So the main goal of the Embedding API is to make waves available across the web, and it's designed in such a way so that to make it easy for users and developers to just stick a wave inside on any web page. Hence, that's what I use the sticky notes picture. So you can embed a wave as a gadget in iGoogle or in your iGoogle or Orchid page. We have a sample gadget here that displays that. In fact, we can just try it out right now. Let's see my Firefox. So let me delete this. So I have my blank iGoogle page, and I will go to add stuff, and I'm going to add that sample gadget that I have listed. And the gadget contains an embedded wave client. It's a streamlined version of our client. Right now it's displaying the search panel. And if you click on this, let's say if I click on the first one, so that will open up the wave. And you can interact with this just like a regular wave client. Say if hello there. Now let's go back to the regular wave client, and you can see that the updates is also being transmitted here. So that was the first example of embedding inside a gadget. Or you can actually embed a wave in any web page using a very simple JavaScript API. So the Embedding API is a JavaScript API that consists of two main objects. First one, we have the wave panel object that contains several functions. First one is load search, and the most important one is the load search and load wave. The load wave function, and if you pass in the wave ID, it will load that particular wave, and it has a set UI configuration that allows you to customize the UI, say like the color, the background color, the font size, and things like that. And you can visit this Google code site for the complete reference for the Embed API. I have a snippet of code. Oh, have a question? Yeah. Okay, so the question was, how does authentication work in our Embed API? So currently, if you want to see an embedded wave, you need to log into the wave itself. So we don't have anonymous access yet, for example. So you still need to log in, and you still need to be authenticated as yourself at the moment. But in the future, we plan to have anonymous access, anonymous read-only access, so that you can just embed your wave in any web page, and people can see it, and probably can only read that, but won't be able to make edits. Okay, one other question was, is there a plan to integrate the Google Wave account with the regular Google account, Gaia account? So the answer is Google Wave account is actually just a Google account with some service bit enabled for you. So you can log into Google Wave with your, say, like Gmail account if you have that service enabled. I think the plan in the future is to enable Wave account for all Google accounts. So like everybody will have a Wave account that has a Google account. Right, so this is a snippet of HTML and JavaScript code that uses the Embed API. So at the top, I have a simple div with WaveFrame as the ID, and I have a JavaScript snippet, a script tag that loads the Embed JavaScript from Wave API appspot.com/public/embed.js. And then I have a bit of JavaScript code that actually uses that API. So first, we need to create a wave panel object and tell like which wave server that you want to load the wave from. So in this case, we're telling it to load the waves from Wave Sandbox. And then we specify a wave ID in the load wave function. And then we create the UI config object and set the color, set font size. And then lastly, we call init, and we supply the div that we created at the top. So basically, this will load the wave inside that div. Let's do another demo of this. So my colleague Pamela Fox in Sydney, she created this sample page for embedding. So basically, she made a simple HTML page that has a YouTube video. And then she wanted to share this with her friends, and she wants her friends to make comments on it. So instead of implementing her own like comment or form, any kind of form with PHP or Ruby on Rails and things like that, she thinks, oh, maybe I can just use Wave embedding for this. And that's when she used the Wave Embed API. If you view the source, you can see a similar JavaScript snippet. So first you load the wave, so you create the wave panel, and then you set the UI config, and then load wave and supply the wave ID, and you call init. And that's pretty much it. And you can see here, she has an embedded wave client below her YouTube video, and people can start commenting on it. And you can also see that she styled the embedded wave panel to match the overall color theme of the site, of the HTML page. So that was our first extension, embed. So now let's talk about, that was our first API. So now let's talk about another API, our extensions API. So our extensions API consists of gadgets API and robots API. If you see the screenshot here, so gadget is this rectangular box here. It's a client side or UI widget, you call it, that allows you to embed content inside Wave. So if embedding API allows you to embed Wave in another website, so gadget will allow you to embed another site or any kind of UI element inside Wave. So and robot, that's highlighted there, is just an automated robotic participant. So robot is a participant in a wave, just like a regular human participant. It has full access to the wave. It can edit text, delete text, add participant, and things like that. And the other thing that I mark here is extension hook. So once you have gadget and robots, you need a way to invoke or trigger them, or add them, or remove them. Things that's why we have this extension installers. So the installers comes with hooks and actions, and hooks is the place or the listener that, or basically the buttons or the places that can trigger those actions. So we have this toolbar here as one of the hook, and we also have the new wave button as another hook for the extension installers. So now let's talk about gadgets. So how many of you guys have developed gadgets before? Just gadgets in general. So a few. So gadgets is basically just a mini web application written in HTML, CSS, and JavaScript that can be embedded in any web page. Well, in any gadget container. So Google Gadgets, so that we have a standard, Google Gadgets that's based on the open social standards, is basically defined in an XML specification that you can load up to a gadget compatible containers, like, for example, iGoogle or Orchid. So for Wave, we also follow that same standard. So you can see if you develop a Wave gadget, you also need to build that XML specification where you put your HTML, CSS, and JavaScript. But on top of that, we also provide some additional features, additional functionality, such as with Wave gadgets, we provide real-time synchronization across real-time state synchronization across clients. So this is really helpful, say, if you're building a game gadget, say if you build a chess gadget, So you can store the state, and then all the clients that are looking at the same at the instance of that gadget can share the same state, like see who's moving right now, what's the current state of the board, and things like that. Also, the gadget has playback support. It supports real-time interactions with different people, and also with robots. So with the combination of robots and gadgets, you can do different things. For example, say you can build a poker gadget with robot, so that the different players cannot tell what's the state of the other player. So robot can store the the centralized information, and gadget can just view different part that pertains to that particular viewer. So the Wave Gadgets API also has support for participants. So in a gadget, you can see who are the participants of the Wave, who's currently looking at the gadget, who hosted the gadget, which means like who added the gadget to the Wave. So the Wave Gadgets API provide access to several different things. So first is to the metadata. I mentioned the host and participants, but it also provides access to the state. You can think of it as the state or the preference of the gadget. And also provide access to the mode of the gadget, whether it's currently in view mode, edit mode, or in playback mode. And I'm going to demo you guys a map gadget that leverage this mode, different distinction of modes. So for example, like if you are in view mode, then maybe you want to have a different toolbar than if you're in edit mode. So gadget receive updates for 3 different things. So first event that gadget receives is if there's any change in the participant list. Let's say if the user adds a new participant, gadget can register a callback that will be called when that event occurred. And we also have updates for state. So if another instance of the gadget updates the state, the other instance will get notified as well. And also for mode change. But gadget can only make updates to one thing, that is the state of the gadget. It cannot change the state. It cannot change like the participants. It cannot add a new participant. Right now, it doesn't support modifying the mode. In addition to these Wave-specific features, we also support the traditional Google Gadget APIs, like Gadget RPC, Gadget dynamic height for the automatic height adjustment, for example. I mentioned before that gadget specification is written in XML, and you can add that XML to any gadget-capable container, like iGoogle or Orchid or even now Google Wave. So you need to host your gadget specification XML file somewhere. So you have several options here. First, you can use the Google Gadgets editor. You can edit your XML there, and it also provides hosting options. And you can deploy your gadget spec to your App Engine application, or you can create one, or any other web hosting options like your website, your friend's website, your blog, or whatever. There are multiple ways for you to add gadget to Wave. So one is, which is probably the most popular option, is from the toolbar menu, and I'm going to demo how to do that, how to add a gadget from the toolbar menu. And second option is programmatically via robot. So our robot API also provides a mean for you to add or remove gadget. And if you have Sandbox account, you can also add a gadget from the debug menu on the top right. So I'm going to show you where the debug menu is right now. So we have a debug menu on the top right. So you click on that and then select extensions, and then you can add a gadget from this gallery here, or you can, if you know the XML, you can just put that here on that text box. Okay, so this is a snippet of code of gadget specification XML. So we specify that this gadget requires several different features. So first one is lock domain for security, so that if you have multiple gadgets in the same container, in the same page, they cannot talk to each other. They cannot snoop on each other's cookies, for example. This gadget also requires this dynamic height feature that allows you to auto-adjust the height of the div where the gadget resides, and the require feature wave that allows you to use wave-specific API. And this is the JavaScript code sample. So we have a wave namespace that provides several different functions. First one is state callback. So basically what this is saying is that if there's any update on the state, call this callback that I registered. So if there's any update, it will call the receive state function here. And the receive state function will get the counter, will get a state called counter, and then put that in the state div. And we call gadgets.window.adjust height to adjust the height of the gadget. And to change the value of a gadget state, you can use the submit delta function. So you call wave.getState.submitDelta, and you can pass in any JSON object, basically just key value pair of any data. Some gadget ideas that we have, it'll be cool if, I don't know, maybe someone has built a tic-tac-toe gadget just for fun, and you can play that with your friend. As I mentioned before, server authoritative poker game, so robots will store the centralized information, and gadgets will render the UI for the different players. Collaborative to-do lists, whiteboard for collaborative like whiteboarding or drawing, or embedded browser. So let me demo two of my favorite gadgets now. So I go to Sandbox, I create a new wave, say that I want to host a party this coming Saturday. So I'll start a wave, say let's have a party. Say when? Saturday. So for the where part, I'm going to insert a map gadget. So in edit mode, your toolbar will have these things like bold, italic, underline that allows you to modify the text attribute, but also has several default gadgets installed. Like first one is the yes, no, maybe gadget, and second one is the map gadget. So I just click on that and to insert this map gadget. So San Francisco. So I'm going to place a marker. I'm just going to approximate where we are right now. Okay, so, and then after that, I'm going to invite some of my friends to this wave. So I'm going to add Seth, going to add David, I'm going to add Dawa. And instead of asking them, hey, do you guys want to go? And then they will reply with yes or no and different blip. Instead, I'm just going to add the yes, no, maybe gadget. And then as a good host, I probably should say yes to this party. Okay, that's a demo of the map gadget and yes, no, maybe gadget. Do you guys have any questions on gadgets? So the question was, there's been some talk where Google is going to provide some marketplace for gadgets so that people can download and probably sell gadgets. So I think there's been a talk about that. That's probably one of the viable options to monetize gadgets. But I don't think we have a concrete plan or concrete roadmap on like when that's going to happen. So the question is, if someone purchases a gadget on one, and he's in one wave server for one domain, and if he adds a different participant on another wave server on a different domain, what will happen? Will that other participant be presented an options to purchase the gadget? I don't know the answer to that, but I would imagine yes. So the other user will be presented with an options to purchase one, or I would say it probably depends on the type of gadget as well. let's say if it's a collaboration gadget, it may make sense to, so that if someone purchases a gadget and he adds someone else to that wave, maybe that other person should be able to collaborate on that gadget, but only on that particular wave. So, so the question was, does gadget falls into the same category as blip as far as like hiding elements inside wave? So gadget is actually just a content of a blip. So if you can, so if you delete the blip, then the gadget will disappear. Okay, how is the data in gadget be presented in for different instance of the gadgets, like for different viewers, different clients? So the answer is gadget state is public, right? So I mean, like all gadgets instance will share the same state. So it really depends on the gadget implementation on how you want to present that information. But regardless, if you use something like Firebug, you can snoop on the state and see the overall content. Correct. So yeah, so one option to have like private data is to store it in robot instead of in the gadget. Then the robot can tell like which gadget instance can view this part of information. Okay, now let's talk about our second extension API. So robots, world peace or world domination? Tough question. So robot is an automated participant that lives in the cloud. So right now, robot can only live in Google App Engine, and it has full access to Wave. So it can edit Wave, like insert text, delete text, annotate some text, make it bold, add participants, add a gadget, add an image, things like that. So basically, the way it works is it listens to events on a wave that it's a participant of, and responds with a series of operations. So while you can think of gadget as a client-side extension, robot is our server-side extension that has more processing power because it lives on the cloud, and it has like more security when it comes to the data access. And currently, robot can only live in Google App Engine, and we provide both Java and Python client library for robot APIs. So you can use the Python SDK or the Java SDK of Google App Engine in conjunction with our client library. And we will lift up this restriction in the future. Right now, we're still working on some scalability and security issues if we want to deploy a robot on different hosting provider other than App Engine. So this is the overall architecture of robots. So for Google Wave, the core server here is the Wave server. That's basically responsible for receiving operations from clients or agents, and also apply that operations and broadcast that to all agents or all clients that are listening to that. So robot proxy is one specialized agent that is responsible for broadcasting updates on waves to the robots that's running on App Engine. So robot proxy will receive updates from Wave server and then package that in JSON format and send it over HTTP to robots on App Engine. And robots will process those events and then reply with a series of operations that it sends back to robot proxy, and robot proxy will push that operation back to the Wave server. And then I have a simple sample robot code here written in Python. Dawa, the technical lead of Google Wave API, wrote this. So you can see it's very simple. It can fit in one slide. Basically, this is a simple robot that listens on a blip submitted event. And then when that happens, it will scan the entire blip content and replace colon and end parentheses with smiley Unicode character. So first you register a handler for that event, and then you have a main function where you register the handler and run the robot itself. So here are some robot ideas. Addy, calculator robot, Facty, fact-checking bot, Spammy, spam blip deleting bot, Arnie, I think that terminates other bots, yeah, we have a talk in the team where, like each developer on Google Wave, we all should make a robot and then add that robot into the same wave and see who wins and see who deletes what robots. And yeah, it's like robo competition, robo war. Publishy and then Maily email integration. So I think it would be cool if someone makes this robot that synchronize Wave with email. Do you guys have any questions about robots? I see. So the question was, when robot gets notified on an event, does it have context on the viewers of that particular wave? So the answer is no, because this robot gets notified on events that happens on Wave, and then when a user or a client opens a Wave, it doesn't generate events, but when someone types in something, that will generate an event. And then robot makes modification on the Wave XML itself that will be shared across different viewers. So I think for that previous question about like private data access, what we can do is for Gadget to talk to the robot directly, make a direct like AJAX call to the robot, and then ask for a certain state or certain data that it has access to. So the question was how much data that we sent from Wave server to the robot. So currently there's a thought that we should improve performance by just sending just delta, but right now we don't have the operation transform stack on the robot side that can process that delta. So right now we're still sending the whole blip content. But as we are working on implementing filtering and search so that you can filter, let's say that if you're interested in blip submitted events, but only if, say, like the blip contains this particular text, for example. That can help to reduce the data as well. So the question was what kind of events that you can listen to in Robot API. So I think, yeah, the best documentation is the code itself. So that's why I'm pulling out the Java doc. So you can listen for various events, mainly on 3 different entities, like on blips and documents and wavelets. So you have like blip deleted event, blip submitted event, document change event, like wavelet blip created, wavelet self-added, wavelet title change, and things like that. And you can see the reference for the complete list. So the question was, if robot generates a blip submitted event, will that robot gets notified on that or not, right? The answer is no, to avoid infinite loop. So the question was, right now, robot only lives in Google App Engine. Is there any reason why it cannot live on any computer that's connected to the network? So I think 2 things that we're still evaluating is the security and scalability implication of that. Because let's say if I have a computer that's connected to the internet, but I live in a rural place with a really slow internet connection, that makes the robot to be not very reliable. And we know we can guarantee with Google App Engine, because we have such close proximity between a Wave server and Google App Engine, we can guarantee that performance won't be an issue in that case. That's why that kind of thing we're still evaluating. So the question was, in this architecture diagram, what's the difference between agent and robot? So agent is something that we wrote and runs on our server farm. So for example, Linky is like a specialized agent that linkify Wave content. So the difference is that robot is an open protocol. It's open for any developers out there that runs on Google App Engine, where agent is kind of like a first-party robot that we wrote that lives on our closed server farm. Now let's talk about extension installers. So you have your gadgets, you have your robots, but you also need a mechanism to share your robot, publicize your robot and gadgets, and also a way to install it. And that's where the extension installer API comes in. So once you build your gadgets and robots, you can build an extension manifest XML file. that basically contains hooks and actions, that defines the hooks and actions. Actions like insert gadget, add a participant. This can be a real human participant, or it can be a robot, because robot is just yet another participant. Or you can create a new wave, apply an annotation, and so on. And then you can define the hooks that will trigger those actions, like in the new wave button, in the toolbar menus, keyboard shortcuts, macros, and so on. This is an example of an extension manifest file for the yes, no, maybe gadget that I showed earlier. So it has name, description, thumbnail, URL, and who's the author, and also the hook location, the toolbar, and then the action for that particular hook. So insert gadget, and this will be the URL of that yes, no, maybe gadget. So this is an example of an extension installer. So it looks like a puzzle piece. It has a thumbnail, URL, and descriptions, and a button to install and uninstall. So if I go to the edit mode, take a look at my toolbar. So right now I have this conference gadget install. Noted here I have this button there. So if I uninstall, that button will disappear, and I can install the extension again, and I can go on and on to install and uninstall. So let me just install the extension, and then I can create a new wave, and I can add that gadget, the Ribbit gadget, to make a conference call. Inactive. Okay, and that's the gadget. So one other thing with extension installer is that once you add that to wave, you can share this wave with your friend. For example, I share this one with Dawa, so that now he can also install these extensions to his wave account. Right, so if you have a sandbox account, you can add extensions via the debug menu that I showed earlier. So debug menu, add extension, and you can paste your extension URL. You can host your extension manifest file in App Engine or any web hosting that you have. And lastly, you can install and uninstall your extension. Any questions on extension installer? I haven't actually tried that myself. You know what? Let's try that. It's inactive. Add my number. So, okay. Probably problem with my cell phone reception too. Oh, now it's active. But I guess I need more than one person to try it out. So, all right. So that was the second P, the platform, Google Wave API. So the third P is Google Wave Federation Protocol. The protocol. Federate this. So as I mentioned before, Google Wave is a product, where Wave itself is a technology. So you can think of Wave as to Google Wave as email is to Gmail. So the goal of Wave Federation is to enable different institutions, different organizations, different companies, different enterprises, basically other Wave providers, so that they can intercommunicate with each other. We have a draft of the protocol specification at waveprotocol.org, and we're still working on this. It's still developing in the open. We're still iterating on it. So if you guys are interested, be sure to check out that and join the Google Groups mailing list for that. So the question was, is part of the work is to have a open source reference implementation? Yes. So we have a Google code. What's it called? A Google code hosting. I think it's a Wave-protocol that you can look up. We have some sample implementation of the Wave server, and also a sample client that you can download and play around. So the question was, is the existing Google Wave client will be open source? So I think last time the plan is we're going to open source a lion's share of our client code, but I'm not sure that we're going to open source like 100% of that, because it may contain some Google specific features that may not pertain to other Wave providers. So the question was, how open is Google on other people developing different wave providers for maybe different platform. So I don't know on top of my head, but you may want to contact Dan Peterson, our product manager, on that. So if you see the screenshot here, so the idea of federation is that, so we have three institutions, Google, Acme, and Initech, and each organization is a wave provider, and with Wave Federation, they can talk to each other, they can send updates to another wave server, and basically users of Google Wave can talk to users of Acme Wave and vice versa. Why do we federate Google Wave or Wave itself? So basically what we're trying to push is the adoption of Wave as an open standard, as a technology, and also to encourage other companies, other enterprises to build their own wave providers. And I think with this in mind, once we accomplish that, the end result will be, I think it will be very beneficial to the users. That gives users the flexibility in like choosing the right wave service provider for them. And also, as I mentioned before, the internet is built on top of open APIs and standard protocols. So we don't want Wave to be yet another siloed communication tools. Correct. So the question was, if I develop a robot, will that work on other wave service provider? Currently, it doesn't. So currently, the API, the robot API, is only specific for Google Wave. So the other thing why we push Wave Federation is we want to avoid like different institutions to develop their own like wave-like systems, but with some minor differences here and there, minor nuances, so that they don't interoperate. So we really want to avoid that situation. That's why we're pushing for this open protocol that everybody can contribute and can adhere to. So the question was, is there any plan to develop some compatibility tests to make sure that your wave server can interop with another wave server? So I don't know about that. You might want to talk with Dan Peterson, my product manager, about that. But I think that's a really good idea to make sure that you're building something that can work with other people wave server. So before we jump into a little bit of technical details on the Wave Federations, so it's very important for us to understand the Wave data model. So under the hood, Wave is basically a collection of wavelets. So a wavelet, a wave can contain multiple wavelets, and each wavelet contains a list of participants that basically controls who can read and write to the document that wavelet has. So wavelet can contain multiple documents. Each document consists of XML document and also annotation that annotate that XML document. So wavelet here is the unit of concurrency, and also it's the unit of wave federation. So when we send updates of the wavelet. So each wave server of a wave service provider runs its own operation transform and concurrency control stack that is responsible for receiving operations, applying operations, and also resolving conflicts that occurs from multiple operations that are coming at the same time. And a wave server shares wavelet updates to federated wave servers. So the way we share the updates is based on the participant of that wavelet, and we check the domain, and that determines like which wave server do we need to broadcast this update to. In the federation model, still only one wave server owns a wavelet. So one wave server is still the canonical owner of the wavelet. So the wave ID and the wavelet ID consists of two parts. First part is the domain, and second part is the unique identifier. And the domain here determines which wave server actually owns this wavelet. So in this case, if I have a wavelet ID of initechcorp.com and then a unique identifier to be conf plus 3sg7, that means if there's any update to this wave, it has to be sent to initechcorp.com wave server. So I talked about this briefly before. So you federate the operations to based on the domain of the participant. So let me just give you a brief example. So the scenario that we're talking here is we have Bob on Acme Wave. He wants to share a wave with Milton at Initech. So Bob creates a wave, type something, and then he wants to add Milton. So Bob's clients will send an add participant operations. So it will have add participant and pass in Milton at initechcorp.com as a parameter to that operations. So Bob's wave server, acmewave.com wave server, looks up initech.com wave server, and probably they do some sort of handshake on connection initialization and stuff like that. And then the Acme Wave wave server will push the update, will push the operations to initech.com wave server. So, and then Initech will request the wavelet history so that it can fully reconstruct the wavelet on their side. And then Initech will propagate this to Milton, and Milton will get the update. We'll get the wave. So, and then for future operations, Acme Wave will broadcast any updates to Initech, and then Initech will send operations to Acme Wave. And after this, so Bob and Milton can happily waving each other forever. So the question was, is there a way for Wave to associate a user to a real user, as opposed to an ID in a Wave server? Like OpenID. So I don't think we have a support for that right now. Yeah. So the question was, is it possible to do some sort of like DNS lookup when we add the participant? I think that's a great idea. I'm not sure if we support that at this moment. Okay. So the question was, what's the relationship between Wave, Wavelet, and blips? Okay. So let me just repeat this part briefly. So Wave is a collection of wavelets, and wavelets can contain blips, which is you can think of it as the document. So I'm creating a wave that has one wavelet that has one root blip, and then as I'm typing and I'm replying, I'm creating more blips in that wavelet in that wave. So wavelet is a unit of concurrency wave federation, and also you can think of it as a unit of access control list. Right now, it's like all users in the same wavelet can see the content of that wavelet. But if you want to make, say, like private reply, that's when you generate a new wavelet that has a different set of participants. So yeah, is there any way to authenticate or to secure Wave? So what we're going to work on is ACL model, where you can determine like who has like write access to this particular wave, and then like who can add or invite other participants to a wave. So I think that's one way to restrict access. Question was, so because robot has access to whole context of a wave, there might be some security concerns with robots. So I think since robot is just another participant, so I think once we have the ACL model implemented for a participant, we can apply the same model for robot as well. And then probably in the future, we can do things like this is when we open up robot to other web server. Maybe what we need to do is to use things like HTTPS or encrypt the JSON that we send out, things like that. So this is a simple diagram that explains the flow of wave federation. So you have a wave client that communicates back and forth with the wave server. That's on the left-hand side is the Acme Waves wave system, and then on the right-hand side is the Initech wave server and remote and host. So basically, the client will issues add participant operations that gets sent to the wave server, and then the wave server will on Acme Wave will use the federation host to talk to the Wave server on Initech.com over XMPP. And then the same thing, if there's an update happening on Initech on that same Wave, it will use the Federation host, send that to the Federation remote on Acme Wave. That's how the updates are being broadcasted between the two Wave providers. So one other thing that I want to mention with this Wave Federation is that it's an on-premise solution, and this might be beneficial for like financial institutions or even like regular enterprise customers, because basically, unless you add a participant from a different Wave provider or different companies, then your data stays inside your network. That lives on your, basically the data stays in your Wave server that sits behind your company's firewall. So this might be useful if you're exchanging data, say about the company earnings or financial results, or even like litigation or things like that. So couple updates on Wave Federation. So far we have produced two documents. So first one is the Federation protocol on waveprotocol.org. We also published the conversation model that includes definition of wave, wavelet, and blip model. We have open source about 40,000 lines of code on that Google code site, google.com p-wave protocol, that contains the wave model and the operation transform stack, and then the concurrency control. We also open source the Fed1, which is the open source reference implementation. That contains basically has a basic prototype of the client server with an early crypto library, and then the client has a command line based client, and for the server it's an in-memory Wave server right now. And also another thing is we just recently opened up a Federation port on wavesandbox.com. So if you deploy your own Wave server, you can try it out to talk to our Wave Sandbox server. Just keep in mind this port is highly experimental, still on the bleeding edge, so try it at your own risk. And if you see any problem, just feel free to post it to our Google groups for Federation. And we also updated the Fed1 client server. Does a better job of displaying the live update, the real-time update with the operation transform. We also published the Google Wave licensing agreement. So we really encourage community-based development. And lastly, if you want to see a full updates about what we've done so far, you can check out our blog, googlewavedev.blogspot, and about our Federation. So now I'm going to give you a brief demo, if it works, about Wave Federation. Okay, so what I have here is a text-based Wave client developed by Acme Wave. You probably can't really see there, but because of the red text. Yeah, so basically Acme Wave is this fictitious company that doesn't like Web 2.0 stuff, so they prefer to develop a text-based client. And then let me try to open a new make a new wave, and then open that, and I say hello world demoing as SF. Okay, and now I want to add myself on my Sandbox account. Okay, you can see here in their streamlined version of the Wave panel. Now it has with Marcel at acmewave.com and Marcel at wavesandbox.com. Now I'm gonna go to my Sandbox account and see. So I just got a new wave at 8:24 p.m. from Marcel at acmewave.com. Right, so let's try one more thing. Let me try to edit this and see what happened. Oh. Yeah, so you can see like all the characters that I have typed are being transmitted to the client here. And then let's say I want to add a new blip. And the new blip appears here. Do you guys have any questions on federation so far? Let me repeat the question. So how attached is the client to the server? So we have a communication protocol between the client and the server. So I think as long as you make sure that it's compatible, so you can definitely do that. And right, so I'm not sure whether we have published that part of the protocol yet, but you can probably look up on how we implement the Fed1 client server and see. Okay, so that was Google Wave Federation. So now let's talk about roadmap, about the future. So recent features that we have implemented for extensions, we have a new action called annotate selections that basically allows you to put annotations on the selected text. So this is very useful if you want to have, like, let's say once you highlight a text and then you annotate that and robot can respond on that. So that really helps the information flow between, like, make it more seamless to communicate or trigger actions on the robot side. For gadgets, we have a mode distinctions for edit, view, and playback. So, and we have a new method, set mode callback, that allows you to register a callback function for if there's a change in the gadget viewing mode. And for a robot API, we for our Java and Python client libraries, we implemented a new class that allows you to auto-generate the capabilities XML, because previously in the Java one you have a static XML and it's kind of hard to basically tell our server if there's an update on that XML file. And then for federations, we recently opened the federation port on wavesandbox.com. This is, I think, as recent as last week or 2 weeks ago. So give it a try. Some features that we are actively working on right now is for extensions, we are working on a new hook that supports regular expressions. This is also to help many different things. One example will be for robots. Say that if you have a regular expression hooks that you install that say that listens to text like map : SF, and then basically when it matches that text, it will do some action, say that insert a robot, and then robot can insert a gadgets and do some various things like that. And you can probably do some calculation, like calculator function with this as well, like min, max, or sum, average, things like that. For robots, we are working on our next version of our wire protocol, our JSON wire protocol. So in our previous version, we have some Javaisms because we are using the old JSON RPC serializer that has things like Java class inside the JSON object, and we think that it makes more sense if we make the wire protocol to be language agnostic, so that people and developers out there can build their own client library, say in PHP or Ruby on Rails, or I don't know, even C++ maybe. Yeah, it will make more sense if we make it to be language neutral. And second thing, one more thing about that is we published a draft of that new wire protocol to the group, and you can you guys can definitely check it out and give us comments if you have, or concerns, complaints, or anything. So we are also working on a new set of APIs that we call the active API. So because right now the current robot mechanism only works on event-based model. So basically you wait until something happens in wave and then robot will get notified. But what we're working on here is that so a new mechanism so that robot can send operations on demand at any given time. So this new API, when we send operations, it will be authenticated using OAuth, and then we'll send it using Open Social RPC mechanism. And once we have this implemented, we're going to publish a blog post or send an update to the blog or the mailing list, and how you can get your consumer key and secret for the OAuth signing purpose, and how can you invoke the API. And for gadgets, we are working on open social JavaScript support that provides common API to access like social information, like who's the friends of this person who's viewing the gadget, or give full access of the social graph of the host of the gadget, or things like that. What we have in store is coming shortly. We are going to work on a new extension gallery that's more dynamic and can be user generated. Improve extension installation flow. And for robots, we want to implement new operations. The two prominent ones are fetch wave and search wave, so that robot can fetch wave on demand, and so that robot can search across different waves also. And with the new active API, it will make it possible for us to implement this new operations. And then we're going to work on robot performance improvements as well, and probably security. And for gadgets, we're going to work on latency reduction and also support for diff and open. And for federation, we are going to open federation port on wave.google.com. That is our public preview instance. And then future features that's coming in the medium term. So for extensions, we are going to implement IATN support, extension store, so that people can browse for extensions and probably monetize their extensions. For robots, we are going to lift up the restrictions on App Engine so that people can deploy robots anywhere, everywhere. For gadgets, we are going to try to implement UI wave libraries, for example, like wave specific, not wave specific, but some building blocks to build things like form, for example. And for Kaha supports and inline gadget supports, that's also to improve performance, and that allows you to embed the gadget as not as an iframe, but inline in your wave client. And Kaha make it safe for you to embed any content. And lastly, for our embedding API, we want to implement read-only anonymous embed access, so that people don't need to have a Wave account to see an embedded Wave, and also more UI options. That's it. I hope I didn't bore you guys too much. Question?
Will the active API allow you to do things like automatically create new waves and add users to waves? So say, for example, I have a every Thursday 1 o'clock staff meeting, and I want to auto-generate a new wave and add these people to it. Will something like that be possible?
That will be possible. So you can use, say, our active API with any cron system, for example, Google App Engine cron, to automate that. basically the Google App Engine cron will kick in on Thursday, and then it will call the robot, and robot will send an active operations to robot proxy that will create a wave and add the participant. So the question is there any mechanism to manage a group, a set of people or groups? So we don't have that mechanism right now, but I think once we have better support for groups and once we have ACLs, then we can do something like that. So maybe restrict certain set of people to be like read-only and certain set of people to be collaborators and things like that. So the question was, what kind of hardware spec that we need to have to run a wave server? 386 and with 100 megs of RAM. No, actually, I'm not the best person to answer that question. So I think you might want to post that to the Wave Federation forum, and our sysadmin can probably help you with that. Oh yeah. So the question was, where do we see the Google Wave team see Google Wave in 5 years from now? So I guess we really hope that we can get a high adoptions, but I don't think we are ready to completely replace email yet. There's still a lot of quirks that we need to work on to do that. But yeah, we're really hoping that with this product we can really help improving real-time communication and collaborations with different people. So we have been trying to dog food Wave in Google. So we've open access, give all Googlers access to Wave, and then we really encourage like all teams in Google to use that. And in the Wave team itself, like we have been using Wave exclusively for our day-to-day communication and also for like writing design docs or share thoughts on things. And I think has been really successful. And I guess we use email only when we need to talk with people from other team, for example. So the question was, what's the integration plan with Google Apps in general? So I guess that's really one of the reasons why we launched Wave early as a preview for developer preview and even for consumer preview, because basically the idea is we want to put Wave out there and then see how the adoption is and see what the consumer thinks, what makes sense for us to do when it comes to integration between the two products. So the question was, is there any way for us to provide offline access to Wave? Right now we don't have that mechanism, but we are using Google Gears for a lot of things, like for image upload, attachment upload. So I think it's probably makes sense for us to also implement like offline access using like Gears or HTML5 technology. So the question was, why would anyone develop their own Wave server? So, yeah, how can you make a company out of like Wave server? So I think one thing is that with Wave, the thing that I see is at least in my team, like we have improved the communication flow a lot by using Wave. So probably like one potential benefit is not from like how much money that we make from using Wave, but also like how much money that we save from using Wave as opposed to other communication medium. That's one thing. The other thing is I think once we have the extension store, that's probably one way for you to monetize your Wave service, by maybe like selling gadgets or selling robots for your service provider. So the question was, how does it work with the Federation protocol when it comes to extensions like gadgets or robots? So so the core of Google Wave is the Wave model itself. So basically, when you add a gadget, that means you're adding a snippet of XML to that Wave, and then the job of Wave server on side A, say on Google side, is to transmit that update and broadcast that to Acme Wave. And then so Acme Wave will receive that updates, and then it's really up to Acme Wave client to interpret that data. So basically, you get an XML snippet of like that. This is a gadget that we send over the wire, and it's really yeah, and that's pretty much it. And it's really up to the client to what to do with that. It's up to the client of the Acme Wave client. Oh, so the XML itself is self-contained. For example, for a gadget, so gadget in the XML, it contains the URL of the gadget.